All right, so let's talk about drill bits. We watched the videos yesterday. Yes, we did. And so that was last note we took was something about the chisel angle, and I put that's the angle included between the chisel edge and the cutting lips of use and that. And then that was then we came out here to item B, and then all about sharpening. Yes.
Oh, the circles and whatnot.
Oh, does that really bug you?
Just distracting.
Yeah, okay. Like, I don't see anything. Sharpening. All right. 1, watch videos. Check. Okay. 2, this way the outline stays on course here, right? All right, things you can modify. You can modify. / control. In theory, when sharpening. Sharpening. 1 is the included angle. What is the included angle?
Angle of the tip.
Yeah, angle of the tip. What is the standard drill bit angle?
118.
118. How much is that on each side?
59.
59 degrees each side. Okay, you can control that. You can move the drill bit one way or the other, and you can make it sharper. You can make it, if it's sharper, what's that for cutting? Softer metal, like plastics, softer metal, or flatter, which is harder steel. Okay. You can control the lip clearance angle. What is that lip clearance angle? Thank you, Harry. That's this angle right here. You probably can't see because I'm holding the drill bit. Let's see what we got here. Lip relief angle is another. I know, I keep thinking that every day. It's this angle right here.
How much it slopes down.
How much it slopes down. Thank you. That's a good way to put it. I like just regular old easy speak stuff. How much that? So you can control that. If you get it inverted, what happens? And you kind of burn through stuff. There you go. It's this angle right here. You're going to burn through stuff. It won't cut. So you got to have a bit of an angle there. What's that angle supposed to be? About 8 to 24. All right. What if it's 7? I probably won't notice. All right. Okay. So we got that. Now let's talk about drill bit speed and pressure. Two, 3. Thank you. Oh, good job catching that. Drill bit speed and pressure. All right. So for soft metals, the included angle should be about how much?
90 degrees.
90 degrees. That's 45 each side. All right, so we are going to use a higher speed. Use a higher speed and low pressure. One of the things that it helps me remember things is if I'm comparing, okay, if I just said I'm going to drill softer metal, and then I'm going to tell you about drilling hard metal, and then you're going to come back, take a test. Oh, crap, man. Was it like push hard? What the hell was it? Go to the extremes. What's an extreme of soft metal? Plastic. That's why I keep throwing in plastic. So if I've got to drill plastic, do you think I'm going to want to drill slow and push real hard? No. All right. Or so pressure would be just instinctively
Low pressure.
low pressure. And now it comes down to, well, do I want to turn the drill bit slow or fast? Well, you're going to want to go fast, obviously, because they're fast. And we'll talk about, Harry's kind enough to bring in, this is a plexiglass drill bit. It has what's called a zero rake angle. And there's no cutting lip on it. It is actually just a flat piece right here that just kind of scrapes its way through. So that's going to have to be turned pretty fast. If it goes really slow, it's not going to. So I want to get through it fast and get it over with. That windshield cracks. So softer metals, higher speed and low pressure. Let's see. For normal metals, I don't know what else to say. Medium. See, the angle is, we already know, 118. And medium speed, medium pressure. You're wondering, what the hell is medium? It's like me going to Starbucks and ordering a coffee. I don't know. I'm medium.
You mean tall.
For high alloy steels, very hard steel, the included angle is what? 140. It's 140, 70 on each side, and that would be lower speed, and high pressure. I guess one way I could try and remember that is, when you get drill motors, you guys probably don't experience it, like, for me. But when I was a kid, we didn't have battery-operated ones. We just had electric ones, and we had two choices. We had the 3/8" drill, which means it would handle a drill bit up to 3/8, and we had the 1/2" drill, which was as big as I was at that age. And when you ran the 3/8 drill, the smaller one, it spun at a higher speed. The 1/2" drill would turn very slow. It did not go fast. It was made for big bits and harder metal, and so it would go at a much slower speed. And I would have to put all the pressure on there. So there we go. There is also, let's see, it's 1, 2, 3, 4. Another way to look at this, which is SFPM. Some effing, I don't know. So let me see. There, I want this one. I want to go to this chart. Current slide. There we go. SFPMs. That is surface feet per minute. So if I were to look at this chart, and I am, so we are. All right, so we have non-ferrous, soft metal, non-ferrous, hard, cast iron, low. What do you want to drill into? Want to do some aluminum here? All right, we're going to do aluminum. Thank you. So all right, so we got aluminum alloy right there. All right. There's the hardness, Brunel hardness. That's the hard. You can actually test the hardness of the metal. I'm sure you guys studied that already with Phil. That is speed in the surface feet per minute. So general purpose, 250 to 350. Let's call it 300. And right there is what it is. The RPM is SFPM times 3.82 divided by drill diameter. So what would be the proper speed to use for a number 30 drill bit? There we go. You should be able to see it all. You see it? So it's 300. The speed is 300. So we'd say RPM is surface feet per minute. Okay, 300 times this constant, 3.82, divided by 30? Divided by drill diameter. So it's a number 30.
You're going to get so many different answers.
Wow, you guys forgot what a number 30 is? What size rivet is that? 1/8 rivet. Therefore, the drill bit is?
1/8.
There we go. Divided by 0.125. So what do you get for a speed according to this?
9,168.
There you go. That's what it says. And then you have a feed rate, inches per revolution. Yeah, I'm not going to figure that one out. I just push. So if it's hard metal, I'm going to push real hard. If it's aluminum, I'm going to push medium hard. And if it's plastic, I'm going to push not so hard. That's it. Push it. Push it real good. That's how much you do it. Thank you for that. Yes?
What if you wanted to find out the hardness of the material? How would you do that, the Brinell hardness?
I just get a hardness tester.
There's that puts pressure on it?
Yeah. Yeah, I don't know. I don't think we have one here, but I had one at my shop when we used to do rocker arm grinding. You had to check the hardness of it. And so you just put it in a fixture and then you push down on it with a certain amount of pressure and then it put a little indent in it. It's not that big a deal. Okay. We covered that. I'm not going to belabor that point. Going back to this. There we go. Let's write down what that means. So you'll forget that is surface feet per minute. So that has to do with the bigger the drill bit, of course, you're going to change your speed on that. That's why they don't just, they use a formula. So we did the same, we did that with an 1/8 inch drill bit. What if it was a 1/2 inch drill bit? So with a 1/8, we ended up getting 9168 by that chart. What if it's a 1/2 inch drill bit? So it's 300 times 3.82, I think it was, divided by 0.5, so 2292 using the chart. If I did it right. Okay, well, there we go. Okay, next on my list. It's a lot. It really is. All right. Number 4, modified. Modified bits for plastic and other soft materials which would be like brass. And I want to say that I got this, it's not in any of the other books, but it's in 4313 somewhere when it talks about drilling plexiglass. It says use a drill bit with a 0 rake angle. And I don't think they tell you what a 0 rake angle is, so I had to figure that out. And so the rake angle, based upon that, is the angle made from the flute to the cutting lip. So I'll put that rake angle is the angle made, got to go up, from the flute to the cutting lip, from the flute to the cutting lip, to the cutting lip. So a 0 rake angle removes the sharp cutting lip and makes a bit that simply scrapes the material off. So Harry was nice enough to bring in, wasn't nice enough to bring in a really large drill bit, so I can show you up here, but he brought in this one. So, all right, so I'm going to pass it around. Everybody hand me a tool chip. So you have the flute right here, and normally you come up to the flute and you know you'd have that little cutting lip right here, like this edge right there, which is not really up, but when I pass this around you go, oh, okay, I get it. So first of all, what angle is this right here? 90, okay, so we know it's for something soft. And you'll see there's no cutting lip. It was actually ground away. And you can do this with any drill bit. I've never bought a plexiglass bit. I just modify them and put a piece of tape on it. It's for plexiglass. And if you forget and try and drill aluminum with it, you'll know in a minute. Yes, I'll pass around. You'll see the 0 rake angleness of that. So in a pinch, you just make it. You put on the grinder and grind that off. So there's nothing sharp. So
You trying to be through movie?
what's that?
Put in a blue windscreen, you can drill all the holes, they don't come pre-drilled.
I didn't have to drill any. I drilled one hole in mine,
It's okay.
and that was only for the glide slope antenna.
We put one in a beach bear and fixed on the windscreen and had to drill all the holes forever.
There's a lot that goes into that. I won't even get into that. Larry will. Zero rake angle removes the sharp cutting lip. Removes the sharp cutting lip. Removes the sharp cutting lip and makes a bit that scrapes the material rather than cutting. And makes a bit that scrapes the material rather than cutting. All right, some tips and tricks here. So I'll call it tips. And now my thing will be all off here. Call it A, I guess, huh? Is that what's next? A. You should always back up your work. Not in the computer way. But you should always have a piece of sacrificial wood behind whatever it is you're drilling through. Don't just drill into stuff, because if it's a small enough piece, you're going to bend it. You're going to bend the material, and so it's just good to have it back up. And also try not to keep your fingers out of the way. I've drilled into my own fingers quite a bit. It's not especially fun. It's fun with somebody else's. It's especially important with softer materials. Not even so much I'm talking like brass or plexiglass. If you're using a bit that doesn't have a zero rake angle and it actually does grab, it will tend to grab and actually pull the drill bit. Instead of you feeding it, it's going to pull the drill motor and you into the hole. And when it gets to the back side of that, it just blows it out. And so if you're doing a window, you'll actually blow out the back side of the window and have damage all over it. And it can get rather large. So that's just the beginning of the end of that window. And, you know, I bought a cheap window for my airplane. I mean, I bought a nice window, but, you know, the plexi for my 182, it was around $1,500, not counting installation. So just the window. Huh?
What would be like a high-end price?
Well, that is high end for 182.
Oh, okay.
Okay, but you want to talk about something that's going to go in a pressurized aircraft that's got heating element. Shoot, I remember when I was in A&P school. I mean, you know, this is before most of you were born. And my buddy, his dad worked out at International at United, Delta, out here at Delta, and they had to put a window in a 737 or something in it, and one of the guys damaged it. It was $50,000. So that was, you know, 30 years ago. So if somebody told me that they bought a window for one side of a 767 or something and it was $100,000, I'm like, yeah, that sounds about right. Now, but that's stuff, some of that's actual glass, but it's, you know, yeah. That's what I'm telling you. And I get on you about, you know, dress your edges and stuff. And we're not doing plexi, but that was the one thing, the window that I bought. You know, it's like, I didn't need to trim it, but I spent a few hours with very fine sandpaper dressing all of the edges because I could see where they cut it with a bandsaw. You can see, you know, it's like they're saying it's ready to go in. Well, not for me. I don't want to buy that again. So I spent an hour or two polishing all the edges so you could actually look through the edge and see into the window. So that's the way you should treat all of the edges. Otherwise, you know, you put it in the airplane, it's going to shake a lot. You have vibration, you know. It's going to suck for me if a year from now I got a crack just propagating right up through the windscreen. Oh, guess what I get to spend my money on again. So All right, this one is, let's see, we'll call it B. For larger holes, start with a pilot hole. Now, in the video that we watched, the guy bitched and moaned about one of those drill bits had a notch cut out of it. And he said, well, that's because somebody had drilled a hole and then used that to enlarge it. Well, he's right. You're going to damage your drill bit. I don't care. I'm more concerned about what I'm working on. And, you know, I started drilling holes more in steel. You know, I learned most of my stuff in cars and then on ships. You know, ships are not known for being aluminum and very lightweight. So, you know, I'm drilling a big, thick plate steel and stuff. And to do that, if I was going to drill, say, a 1/2-inch hole, where was that drill bit that you guys are looking at? It's about 1/2 inch, I think. Is it 1/2 inch?
Yep.
Yeah, it's about half. So I'm going to drill a 1/2-inch hole. I'm not going to drill a 1/2-inch hole. I'm going to start with an 1/8 inch and drill what I call a pilot hole. And then, now according to the guy in the video, you want a pilot hole just big enough to get your chisel point in. Now, if it's thick enough and strong enough, I'll go 1/8 inch, then I'll pick something in the middle, and then I'll pick my final. I'm going to do 3 or 4 holes to get all the way up to 1/2 inch because, man, it's a lot of work. So, but if I want precision, like just say I'm doing aluminum, you can take a 1/2 inch and punch a hole through aluminum. You know, it's not that big of a deal, especially if you have a drill press. Just get down on it, it'll go. But for precision, I like to drill a number 30 first, or 40 maybe, and get that hole perfectly lined up and started, and then drill it through, and then go to something that'll follow it. So it's just more precision. Shouldn't have to say this, but do not hold material in your hand. You'll learn it one of 2 ways. Either you will learn it the hard way, or you'll see somebody else learn it the hard way. Your choice. I was fortunate enough that I learned it both ways. So, yeah. I think I told you guys this story. Adele clamps. We'll talk about Adele clamps. It's one of the hardware things. It's these stupid clamps that everybody hates.
Yeah, it's stupid.
Yeah, and it had like for number 10, so 3/16 inch hole. He needed it to go a 1/4 inch bolt to go through it. So he hooked up a drill bit, a 1/4 inch drill bit, and the drill press, turned on the drill press, put his finger through this thing, you know, hold it like that. It's a clamp. And so he just put his finger through the clamp, held it up there, and started drilling. Well, when that drill bit, it's thin metal, when that drill bit caught and spun it around, it ripped his finger mostly off. So, the hard way. I've been lucky. I've just drilled a couple number 30s and 40s in my hands, but only part way through, never hit bone. So, don't do that. All right. I have wear safety glasses on here, but I'm not going to waste the ink because you're not going to listen anyway. All right. Anybody ever get metal in your eye?
Yep.
I have.
Aluminum or steel?
It was off a wire wheel brush, so it was steel.
Steel?
And it was a mess. I went to the doctor for it.
Yeah?
My GP tried like 2 or 3 different doctor's appointments to get it out. He never was scratching, driving me crazy. Couldn't get it out. He tried like magnifying lenses, all kinds of crap. Finally, after about 2 or 3 weeks of just suffering with this thing, they sent me to an ophthalmologist who had like special tools. It was like an inpatient surgery kind of deal for them to get it out. Seriously. And it felt great when they got it out, though.
What was that?
I can't wear contacts because I can't even put eye drops in. I'm just too, I don't know what it is. My eyes are too sensitive. I see that thing, I'm like backing up. So I got a piece of steel in my eye, and it woke me up in the middle of the night. And to this day, it's probably one of the most painful experience I've ever had. I couldn't stand it, and it was excruciating. And in the morning, we went to one of those dock-in-the-boxes, and he put some dye in my eye, and he goes, "Oh man, you got a piece of steel in your eye." And he goes, "We got to get it out." So how are you going to get it out? He says, "Well, I got to reach." I said, "Man, you can't touch my eyeballs. I don't know. It's something about me." He goes, "Well, we're going to have to." So they put some deadening stuff in there, and he couldn't get it out. He said, "It's embedded itself, and it's rusted into your eye. The only way we can get it out is to drill it out." And so with your eye wide open, you see this drill bit coming right at you. And you can't move or flinch. And he sat there and he drilled it out. And it was, for the next 3 days, I was in significant pain.
Yeah.
So,
And Kevin, by the way, that was happened to me about 15 years ago.
Yeah?
I was being a dumbass and not have safety glasses on. I was using a wire brush.
yeah, I was undoing a bolt underneath a car. And it was just because of the lock nut
Okay.
had grabbed onto metal, and it was just a lock nut thing. But
Well, I learned
so
to protect my eyes, I'll tell you that.
you'll learn. So
I don't want to learn. I'm gonna
You can-
get some goggles.
you can wear-
Every time I come in, I'm gonna strap up.
when I was in the Navy, so remember Titus, out on the fantail, it's the back of the ship. We had one guy in deck division. He was over there in the corner grinding away with the wire wheel, just cleaning something on the ship. And this guy was in my division. I don't know. He just went out there for a break because we go to the back of the ship for a break sometimes. He just walked out there, and this thing flew all the way across the freaking side of the ship and nailed him in the eye.
Dude, I've been so mad. Like, what are the odds? Like, he shoots across the
Those wire wheels.
You're not even one grind.
When I was working at air repair, when I was working at air repair over the COVID break, I used a wire wheel. I was like, ow, it just hurt. And I mean, it was just embedded all the way down my shirt. I'm like, what the hell is with your wire wheel? Like, oh, you got to watch out for that. I'm like, bleeding out.
It does not.